In your textbook on pages 937 to 938, they go through a kind of drawn out and very hard to visually follow, because they're talking about a three-dimensional shape and you're looking at it in 2 dimensions, and I can understand how it can be hard to follow. But they go through and they show you why the formula for the volume of a pyramid is what it is. It's here. And so that's the main thing that you need to be mindful of. Notice that the height that we're talking about is from the vertex of the pyramid down to make a perpendicular segment to the base. So that's the height that we're using here. I want to make a big point about that, because when we get to surface area in the next module, we'll be using a different height, and it'll be called by a different name. And then when you see a capital B, that's referring to the area of the base. So in example 1, part A, they're solving a volume problem. So notice the dimensions that we have for the square pyramid. They found the volume of the pyramid by finding the area of the base by multiplying 24 times 24. And then they plugged it into the formula for a pyramid. And they said each block is 4 by 4 by 4. How many blocks would I have to use to build the pyramid? The volume of a cube is side squared, so I know the volume of each block is 64. And then they divided the volume of the pyramid by the volume of each block to find that Ashton needs to use 144 blocks. Similar idea here. We're going to find the volume of the Great Pyramid of Giza, use the dimensions of an average block, and then find approximately how many stone blocks were used. All right, so the area of the base is the area of the square, whose side lengths are 230. So 230 squared is, let's type that into our calculator, 230 times 230, that's 52,900 square meters. So the volume of the pyramid will be 1/3 times that area, 52,900, times the height of the pyramid, which is 146. And so the volume will be approximately 2,574,466.67 approximately cubic meters. Next, we're going to find the volume of the average block. The volume of a rectangular prism is given by the formula length times width times height. So the volume W of the average block will be 1.3 times 1.3 times 0.7, which is 1.183. So we're going to divide V by W, the volume of the pyramid, by the volume of each block. Oh, I didn't see that blank there. Let's fix that. So the approximate number of blocks is, and we go in our calculator to type in 2,574,466.67 approximately, divided by 1.183. That is 2,176,218.67, but we're talking about blocks here, so we're going to round to the nearest whole number. Similar example, I have a piece of pure silver in the shape of a rectangular pyramid, and I'm trying to find the density of silver. And so we're told the mass of this pyramid, and we're going to take the mass divided by the volume in order to find density. So volume is 1/3 base area times height. Base area is 2.5 times 1.5. So in my calculator, 2.5 times 1.5 is 3.75. So volume is 1/3 times 3.75 times my height of 1.5, which is 1.875. While I'm thinking about it, I want to say this. Please don't round. It's 3 decimal places. Just write the numbers down. It's not going to kill you. The more times you round, the reason why I'm saying this is, the more times you round, the further and further you get from the truest possible answer. So let's get the truest possible answers. The density is the mass, which is 19.7 grams, over 1.875. So 19.7 divided by 1.875. The density is approximately 10.5 grams per cubic centimeter. Finding the volume of a composite figure. Again, remember, we can add or subtract to find the volume of composite figures. And so what we have here is a pyramid that's been removed from a prism. So they found the volume of the prism, length times width times height. They found the volume of the pyramid, and then they subtracted them. So the volume of the composite figure is 3,000 square feet. Same idea in part B. First thing they want us to do is find the volume of the prism. That's 30 times 12 times 15. So in my calculator, 30 times 12 times 15 is 5,400 cubic centimeters. The area of the base is 30 times 12, which is 360. So that means that the volume of the pyramid is 1/3 of 360 times its height, which is 15, which gives us 1,800 cubic centimeters. Subtract the volume of the pyramid from the volume of the prism. We get 3,600. Couple more composite figures. In your turn number 5, we have 2 pyramids base to base. Pyramid of each has a height of 6, and the bases for both of them are squares with a side length of 6. All right, so capital B is 6 times 6, which is 36. The volume of one pyramid would be 1/3 BH. Since I'm finding the volume of 2 congruent pyramids, it's 2/3 times B times H. Which is 192 cubic inches. Here we've got a rectangular prism with 2 square pyramids on top of it. So the volume of the prism is length times width times height. So that's 10 times 5 times 2, which is 100. the two square pyramids are congruent, so the volume of the pyramids is going to be 2/3 base times height. So let's figure out over here what the base area is for those pyramids. They're square pyramids, so that means that this 5 here is also a 5 there. So the base area is 5 times 5, which is 25. So I have 2/3 times 25 times this height of 3. And I believe that's going to be 50. So then my composite area, or volume, excuse me, is 100 plus 50, which is of course 150 cubic feet.